Hey everyone, hope you're doing well. Welcome to a new video. In my previous video, I demonstrated how to install and use K6 for load testing. In this video, we'll look at another popular tool called Locust. Locust is an open source load testing framework written in Python that allows us to simulate hundreds or even thousands of users interacting with an application. It is widely used for performance testing and also can be used by security teams to perform controlled load generation during authorized assessments. By the end of this video, you'll know how to install Locust, create your first test script, launch a web dashboard, run a test, and analyze the results. So let's get started. So similar to my previous video on K6, let's start with the installation. First, we need to ensure Python and pip are installed in your system. You open Command Prompt or PowerShell if you're using Windows system. In my case, I'm running WSL on top of my Windows. So let me open my screen and run the command pip install locust. This is how you install Locust. Uh, in my case, I have already installed Locust, so I'm skipping this part. After installation completes, we can verify it using the command locust --- version. So as you can see, I'm using Locust 2.44.3 here. If you can see the version number, then the installation was successful. Now let's create our first load test. For that, we need to create a Python file. In our case, we are creating a file called locust.py. I have already created a Python file and entered the script here. Let me just use nano locust.py to see its content. As you can see, we have already entered the script and kept the Python file ready. The first line here are import statements to import three components from Locust. First is HTTP user, which represents simulated users. Second is task, which is used to mark actions that the user should perform. And third is between, which helps us introduce delays between requests so the traffic looks more realistic instead of sending requests continuously. The next line is where we create a class called website user. Think of this as a template for every virtual user that Locust will create. If we launch 100 users, Locust will create 100 instances of this class and execute the tasks defined inside it. The next line here tells Locust to wait between 1 and 3 seconds before performing the next action. The task decorator tells Locust that this function should be executed by users. The function self-get-client sends an HTTP GET request to the application's homepage. And the next function, we are sending request to the search page. Once the file is created, we can close the file by saving it, and then we can run the command locust-f locust.py, which should start the Locust successfully and make the web interface accessible on the default port. In this case, the port is going to be 8089. So let's do localhost port 8089. So as you can see, we are able to access the Locust interface. Inside the dashboard, you'll see several options. Host, which asks for target URL, number of users indicating how many virtual users can be simulated, and spawn rate indicating how quickly users are added. For the demonstration purpose, we will maybe add the number of users as 50, maybe spawn rate as 5, and host we will enter http example.com and start the assessment. As you can see, the number of users are increasing along with requests per second. The failures percentage is indicating how much of the requests are getting failed and how much is getting success. And as you can see, the status is in running state currently. Now let's look at the metrics. As you can see, there is a statistics dashboard which shows the entire statistics of the assessment. We have charts which shows us a graphical representation of requests per second, number of requests failed, and response times as well. Then we have failure tab, which shows us number of failures that has happened and the request that is being used. In this case, it's get request, and the exact parameter, which is search parameter, which is the same parameter that is getting appended in the URL. We can also see exceptions if there are any exceptions that have occurred during the process. We can view the current ratio, and we can even download the data in the form of CSV. And if you want, we can view the logs as well. So this is how you can, run Locust and use Locust to simulate a DOS assessment or controlled DOS assessment. And since we are happy and satisfied with the result, we can even stop the request. If your application handles a load successfully, you should see stable response times, low failure rates, and consistent throughput. If limits are reached, you may observe increased latency, 429 responses, timeouts, and even server-side errors. These observations can help identify bottlenecks or defensive controls. And that's it for the Locust setup and demonstration. In a just few minutes, we have installed Locust, created a test script, launched the dashboard, generated traffic, and reviewed the results as well. Locust is an excellent tool choice when you want Python-based flexibility and realistic user behavior simulation during performance and security testing engagements. I hope this video was helpful and useful to you. If you enjoyed the content, don't forget to like the video, subscribe to the channel, and share it with the others interested in cybersecurity and security testing. Thanks for watching, and I'll see you in the next video.